whether it's for agriculture, horticulture, forestry or peatlands. We would do a lot of research on sort of how soil delivers on multiple ecosystem services. And it's all about how healthy the soil is in terms of its resilience. So we want a healthy soil will be resilient to climate extremes. So for example, if we get periods of flooding, a healthy soil will recover and bounce back. Likewise, if we have periods of drought, a healthy soil will be able to recover and bounce back. But if it's not healthy, if it's depleted, then once we get extremes of climate or other stresses, if the soil is not healthy, it's not able to recover as well than if it was healthier. So soil health is all about the functioning of the soil in that particular land use and how it can withstand stresses. Okay, so how we know if our soil is healthy or not? So we need to monitor our soil. We need to measure properties of the soil, which we call soil health indicators. And then we can monitor soil over time to see whether the health of the soil is improving or if it's declining. So we use a lot of sort of innovative techniques in our research to kind of measure and monitor soil. So AFBI is we're the scientific leader behind the Soil Nutrient Health Scheme, which many of you here may be aware of, where we are testing soils across Northern Ireland, every field, over a 4-year period, and looking at the nutrient content of the soil and advising farmers on how to manage the nutrients within their soil on their farm. We use a lot of innovative technologies in this project, such as LiDAR, to look at runoff within fields. We're looking at above ground biomass, which is hedgerows and trees, to look at the carbon stocks on farms. And we also use technologies such as weather stations, above ground sensors, and within soil sensors to look at things like soil moisture content, soil temperature, and monitor the status of the soil over time. Okay, so soil health is made up of chemical, physical, and biological properties. So your chemical indicators, these would be nutrients, the pH of the soil, and the organic matter status of the soil. Physical soil health refers to the structure of the soil, how well the soil drains, and if there's any evidence of things like compaction. And then your biological health is things like earthworms and the microbial activity of the soil. And so your physical, your chemical, and your biological properties, they all interact together. And overall, that is the combined 3, chemical, physical, and biological, that makes up your soil, the health of your soil. Okay, so I'm going to first of all talk a wee bit about soil chemical indicators. So these are your nutrients. So for agricultural soils, these would mainly be your nitrogen, your phosphorus, potassium, and the sulfur content of your soil. These are the main soil plant nutrients. Chemical indicators also your pH and the organic matter status of the soil. So the Soil Nutrient Health Scheme, we're measuring the chemical properties of soils all across Northern Ireland. So this is a 4-year scheme. It began in 2022 and it finishes next year in 2026. So Northern Ireland has been divided into 4 zones. So in 2022, we started in the southeast, County Down. This is a free soil sampling which was offered to all farmers within that zone. We had over 90% uptake by farmers in Zone 1, which was really pleasing. Then in 2023-24, we moved into Zone 2, which was southwest in Fermanagh mainly. Then we moved up to Zone 3, which was the northwest. And now, this winter, we're sampling Zone 4, which is mainly County Antrim. Okay, so we've offered this free sampling. So every farmer who signs up for this gets all the fields on their farm sampled. And we give them the values of the pH of their soil and those main nutrients. And this helps them to form a nutrient management plan for their farm. And there's also training in how to interpret soil, the results of your soil testing, and how to manage the soils on your farm. So really, unless you measure your soils and the nutrient content, you don't know how to manage your soils appropriately. So this tells you, for example, what your phosphorus status is, whether you need to apply phosphorus or not, how much potassium's in the soil. That's particularly important whether you're trying to grow silage or an arable crop, for example. You really need to get your nutrients optimum. So we don't want surplus nutrients in the soil, and we don't want deficiencies. So you're trying to hit the optimum amount of nutrients in your soil for whatever crop you're growing. We're also looking at carbon content of soil. So your carbon is your organic matter. So this is really, really important for your soil health. And we're measuring the carbon stocks within the soils across Northern Ireland. We're measuring that in terms of the soil, and then the above ground biomass, which is the hedges and trees on farms. So you can get an idea of the carbon stock on your farm. So we want soils to be as high in carbon. So usually if you're in a grassland, if you're mostly grassland, your carbon stocks will be quite good because the soil is covered if it's in a permanent grass crop. If you're an arable where you're constantly ploughing up a soil, your carbon will be lower because you're kind of, anytime you plough up a soil, you get a decline in carbon. So we have measured, so we're taking in-field samples of the soil, and then we've also done LiDAR, which is an aircraft which is flown across Northern Ireland, and we can see the amount of hedgerows and trees on a farm, and we can measure the carbon in the above ground biomass. Okay, so I've got just some images of some typical soils. So this is from the Countryside Survey, which has been happening in the last 2 years. So these are just what you would expect in soils across Northern Ireland. So this would be a typical woodland soil. You can see there's a kind of crumbly texture there, lots of fine roots. So woodland soils would be slightly drier, a lot of roots in them take out the water from the soil. And the pH is generally quite acidic with the leaf litter. By contrast then, if you have an improved grassland, you can see the difference in what you would see in the soil. So a typical improved grassland would be quite intensively managed. You can see it's quite dense there. There's an element of compaction in a managed soil for grass, and there's machinery going across that field. There's slurry tankers, fertilizer spreaders. So you can see in that core, the soil looks more compressed, slightly compacted. And that's what you'd see in a managed soil compared to like a woodland soil. The pH there is 6.4. So this soil would have had maybe inputs of lime. So that would be like the optimum pH for a grassland soil. And then another example, so this is what a typical bog soil would look like, or a peaty soil, very black in colour. So generally, if you have peaty soil on your farm, the more organic matter content, the more organic matter in the soil, generally a darker colour. So typical, there'll be a lot of peatland across Northern Ireland, and generally it would be like a dark, very dark colour. The pH would be very acidic there, so that soil is pH 4, just under pH 4. And that would be the typical pH of a peaty soil. It's very important if you have peaty soil in your farm not to apply lime to it and try and increase that pH like you would for a grassland soil. So a peaty soil is naturally very acidic. If you start adding lime to that, start adding nitrogen to that, you get a lot of emissions of carbon dioxide, you get a lot of emissions of nitrous oxide. So it's important if you have peatland soil in your farm, you need to manage it appropriately. Okay, so I'm going to talk a little bit about physical indicators now. So by physical health, we're talking about the structure of a soil, the drainage and the aeration of a soil. So for you have a healthy soil, you have a nice crumbly structure, the drainage would be good, and there'd be plenty of oxygen in the soil. So generally soil becomes compacted by machinery. So if you go onto fields which are wet, particularly they're more vulnerable to compaction. So if you go out with a slurry tanker on a wet soil, you can't compact it, and you're essentially compressing the soil. You're taking the oxygen out of it. And it often happens with grazing animals as well. There's areas of poaching. If you have a very heavily stocked field and you go out when the conditions are very wet, you're more likely to compact that soil. And you can tell if a soil is compacted if it rains and you get areas of flooding in a field, the water just can't drain through it. So you may see if parts of your field are continuously kind of flooding, drainage is poor, it generally would be that soil is a bit compacted. It also affects growth. So if your soil is compacted, you won't get the yields. It'll not grow as well. There's less oxygen in it. It's harder for the roots to penetrate down into the soil. And this would generally happen often where there's repeated passes of the field by machinery. So you can see tracks in your field where you repeatedly go across with a tractor. You would generally, those are areas of the field which get compacted. So we would advise particularly not to go out with heavy machinery after when the soils are very wet. And it's very difficult to sort of manage this because of the amount of rainfall we have, but it's particularly in the springtime. If we have a wet winter and you go out too early with slurry, for example, that is when you're at risk of compacting your soil. So you can get an element of surface compaction, which is okay. Your soil will recover a bit from surface compaction. But if you get really deep compaction, deep into the subsoil, the only way of maybe getting rid of that would be reseeding or ploughing up the soil or deep subsoil, in which it is expensive, and you wouldn't want to be damaging the soil to that extent. So we would try and minimize any compaction of soil. If it is compacted, you also get like a very sticky sort of appearance, and particularly, clay soils, you can get a cloddy sort of appearance to the soil. Maybe you can get a bit of blueness colour into it, and this would indicate there's less oxygen in the soil. So another reason for avoiding compaction is to try and, once you compact the soil, you're taking the oxygen out of it, and that affects your biological activity and your overall soil health. Okay, so in Northern Ireland here, we all know we get a lot of rainfall. So there's parts of Northern Ireland, particularly, which the dark orange colours there, out in the west particularly, there'd be soils there which maybe would be saturated or above field capacity for over 250 days of the year. So these are areas where there's a lot of rainfall, the soils will be wet well into the spring, and these are areas where they're vulnerable to becoming compacted, and it's difficult for the farmers there to manage, even in terms of grazing. That window for getting grazing animals out, if you're in any of those areas with very high rainfall, you need to be very, very careful, particularly in the springtime, going out too early with machinery or animals, and then also in the autumn as well, because that will affect your overall soil health. It also increases the loss of nutrients from soil. So if your soil is compacted, once it rains, the water sometimes just runs across the surface of the field. It can't infiltrate down into the soil, into the field. It ends up just running across. And this is particularly an issue if you have slurry out or fertilizer, and a lot of rainfall, we get a lot of this runoff across the surfaces of our fields, because either it's near particular gateways or tracks where the soil is just compacted, the rain can't filter in, it just runs across the surface, and you take with it nutrients, and that's what gets into our waterways then. And we have this landscape in Northern Ireland where we have a lot of hilly fields, a lot of drumlin topography, the high rainfall, we get compacted soils, and then water just runs across the top of fields, the surface. And it's really difficult to manage this, but it's just to be aware of it, that this is a big problem for us, and we have to try and, it's a pathway for loss of nutrients from our fields. Okay, so I'm just going to go on to biological indicators now. So this is things like your earthworms, but there's also a lot of microscopic organisms within soil. So within a teaspoon of soil, there are more microorganisms than there are people on Earth. So your soil is full of life. A lot of organisms in there we can't see. You can only see them in a microscope, but they're all really important, and a really important role in soil and soil health. They're breaking down organic matter, they're releasing nutrients which then are taken up by the plants. So your biological activity is one of the key properties of soil that makes the soil healthy. And your biological health is very affected by soil pH. It's very affected by sort of environmental sort of extremes, rainfall, drought, things like that. That all affects the biological activity of your soil. And one of the things we look at, the easiest thing that we and farmers can look at in terms of biological health is the amount of, say, earthworms in your soil. This is an easy measure that a farmer can do on their farm to indicate how healthy your soil is. Okay, so a simple way of doing this, if you dig a pit, a 20 by 20 by 20 centimetre kind of pit in your soil, and if you sort that, and if you count the number of earthworms, so if you get over 20 earthworms in that area, that would indicate your soil is very healthy in terms of biological activity. If you get less than 9, you'd maybe be concerned, or maybe it would indicate that your soil wasn't as healthy as it could be. So one of the things we look at in our research are what are these indicators to show us if your soil is healthy or not. And one of the easiest, simplest things you can do on your own farm is to look at earthworms. So some of the research we're doing are looking at other ways of looking at biological activity. So we don't want to always have to go back to the lab and take very expensive lab measurements. We're looking at other things that you can do in your soil. Look at the colour, look at, probes in the soil. There's different apps now which can indicate very simply and cheaply if your soil is healthy or not. So we do a lot of research on soil health indicators, both chemical, physical and biological. And this is to see if there are any cheaper, quicker ways that a farmer can use without having to send samples to a lab of whether their soil is healthy or not. And one of the things is your earthworms, whether you have signs of compaction on your fields, the colour of the soil, if you dig a pit, what your soil looks like. Even if you're getting flooding areas, you can see if your soil is not draining well, it would indicate there's compaction there. So there's a lot of wee simple, cheap things you can do to indicate the health of your soil on your farm. Okay, so soil, it's a really complex system, and it's constantly responding to these stresses from the environment. So, your rainfall, the temperature, the pH, all your soil is really active. All those microbes I was talking about there are working away constantly throughout the year. So you would have your winter time where things are kind of more dormant. The plants don't grow. Everything kind of slows down in the winter. And that's kind of like a reset for soil. And then once we get into the spring, there's suddenly a burst of activity. Once that soil heats up, so the microbes and things in your soil are very responsive to temperature. So whenever it heats up in the spring, you get a burst of activity. And this helps your crops and your plants grow because the nutrients are released, they're able to be taken up. So this cycle through the year of biological activity in the soil in response to the environment, it's happening, it's all natural, and the healthier your soil is, the more balanced it is, the more it can react to stresses and temperature changes and high rainfall or periods of drought. Your soil will adapt, it will respond, and it'll be sustainable long term. But things like, pesticides, any chemicals you put into your soil, your biological activity has to react to those, adapt. And so there's things like, we have to be careful with pesticides. They all, chemicals into soil, they all disrupt that natural balance in the soil. Okay, so and some of the future challenges we foresee as scientists, so the climate extremes is sort of one of the biggest threats to soil. So we have seen that the last few years we've had a lot of maybe tendency to wetter winters. Maybe we don't just have as many deep freezes in the winter anymore. It's kind of been milder, wetter. And so our soils are staying wetter for a greater portion of the year. Coming into the springtime, the temperature, once they're wet, they're colder. So it takes them longer to warm up in the springtime. You might get a late growth in the spring for things to grow because the soil is staying wet for longer. You can't go out with get slurry out because the soil is so wet. So we see this as a challenge going forward. How do we adapt to any changes in the climate if we're going to get more of these wetter winters? How do we manage our soil? And then also in the summertime, if we get like this summer, we've had quite a warm, dry summer. But last summer was a lot wetter. So how do we manage this, and how do we sort of protect our soil health? So if your soils are wetter for a greater portion of the year, there's more likely to be compaction there. It's harder to get out with your management activities without risking compacting the soil. So we're in our research thinking, how do we manage this going forward? So this is the only graph I have here. So this is looking at nitrogen. Once you add nitrogen to soil, there's always losses of nitrogen. So nitrogen is our main plant nutrient here, but it's very easily lost from soil. And those spikes are where a farmer has applied nitrogen and then it has rained shortly after. So the spikes are, if you apply fertilizer or slurry and you get a few wet days after, you're going to lose nitrogen from your soil. It goes up in the air as nitrous oxide or it's leached through. So nitrogen is one of the hardest things to manage, but you really need it for crop growth. You need it for silage, an arable crop, vegetables, whatever you're growing, you need nitrogen. But it's trying to manage that, and it's trying to get nitrogen on in that window where there's dry weather. Ideally, you want a few dry days after applying. So the red arrows are where the fertilizer has been applied. So the middle period, June, July, this was in 2023. There was a good, nice dry spell in the middle of the summer. Nitrogen was applied. It was all used by the crop. There weren't as many losses, but then you see nitrogen applied at the end of August, a lot of rainfall in September. A lot of that nitrogen just went up in the air or it leached down through the soil. So these are nitrous oxide emissions to the air. So it's hard. This is how we manage nutrients and avoid loss. Okay, so it's these wetting and drying cycles of the soil. So this summer we've had a bit of a dry spell. Now we're getting wet. So any nitrogen that's still in the soil or any nitrogen we apply, you're going to get a percentage of that lost up into the air. So we want to try and, sometimes it's hard. There's not a lot we can do about it, but it's being careful when we apply so you don't lose it. We're also doing research into alternative fertilizer products, so like pelletized, for example, poultry pellets, compost, so there could be garden waste, food waste, sort of biochar, all these alternative products. And these are more organic products. The nutrients are released more slowly over time. They do add organic matter to the soil, so compost and things like that is really, really good for soil, really good for soil health, full of organic matter, full of carbon, but the nutrients are released slowly over time. They take a long time to break down. Compared to like a fertilizer, so if you add artificial fertilizer, the nutrients are immediately available. But if these other organic products, the nutrients are released more slowly over time, but they are really good for soil health. So we're looking at some novel products that are on the market, sort of, and the nutrient ratios of these. So some of these products are very high in nitrogen, some are high in phosphorus. It depends. You need to know what's in these products when you apply them to get the balance right in terms of nutrients. Okay, so biochar is a product. It's more like a soil conditioner rather than a fertilizer. So biochar is produced by the pyrolysis of woody material, for example, willows. It could be also from organic material like digestates and things. You get like a black charcoal-y type product, and you can plough that into your soil, and it's very often used to increase the carbon content of the soil. We have found in our research, though, that also it holds on to nutrients. So biochar, even though it's this fine black kind of powder, if you look at it under a microscope, it's actually this really porous structure. So whenever you add biochar to soil, we have found that it holds on to nutrients. And it can it can take phosphorus out of your soil, it can take potassium out of the soil, but it makes it, it holds on to those, and then it can release the nutrients more slowly over time. So biochar is actually, while it does increase carbon, it's actually doing a lot for phosphorus, potassium, and we're doing research on this now. Is biochar a good thing to be adding in Northern Ireland? Like, how do we plough that in? Do we surface apply it? So we're doing a lot of work in this now and showing how it holds onto nutrients, and looking at the release of those for crop availability. We're also doing work on different technologies. So nowadays you can, very often, a lot of new tractors are fitted with GPSs. So you can see the tracks around the field. You can see, so you're not doing multiple passes of the same part in the field. A GPS on a tractor will show you exactly where you've gone. It can help you apply your fertilizer more evenly, your slurry more evenly. A lot of new tractors are fitted with GPSs now, and they can have a role in helping you manage nutrient applications and help you prevent compaction across a field. If you have a yield map, or if you know that parts of your field are higher or lower yielding, you can actually manage nutrient applications and apply them depending on yield across a field. So we know yield can vary quite widely across a field. You can get 3 or 4 tonne a hectare difference in grass growth across one field, and it's often due to things like nutrient distribution or compaction. But if you have a GPS, it can and if you know where the yield is higher or lower in your field, you can sort of manage your nutrients better, where to apply more or less nutrients. We're also looking at things like weather stations, the role of like constantly monitoring soil moisture, soil temperature over time, so we can see how our soils are changing across Northern Ireland over time. These are the long-term monitoring programs. We can see the annual temperature of our soil, whether it's getting warmer, colder. Just that cycle of soil moisture and temperature is very important. Okay, so this is our vision for healthy soils across Northern Ireland. We want to enhance and protect our soils, so we want to look after our soil health through better management, looking after our nutrients, minimising compaction, and trying to build that biological activity. So the healthier your soil is, the more resilient it is to any extremes or shocks that are coming. And this is how you build that health over time. This is our vision through research, looking at techniques to manage our soils better. And this is how we will build a healthier soil. Okay, so I'm happy to have any questions. Yeah.
Hi. Do you have a report out after the 4 years to say what your results have been, what your findings are on the organic soil? Or is it a live thing that you just look online to see?
So the farmers get their own reports for their own farm. So we're kind of looking at a national scale, so we can map the nutrients across like a Northern Ireland scale. We can kind of see the distribution of nutrients, but the farmer gets the report for their own farm, so they manage the nutrients themselves on their own farm through like a nutrient management plan.
I suppose I'm just asking, is there going to be out of this a benchmark that we're going to try and then improve upon? Because obviously you find out what you've got.
Yeah.
But clearly, from the amount of flooding and compaction, etc., lots of hedgerows and pushing that water, etc., you can see going on for years and years and years. You would be able to see, well, are the methods that we're then applying and teaching farmers to use, are they actually having an effect?
Yes, so we have to keep monitoring. So it's only through monitoring, say every 5, repeating sampling, we can see if there's any change. So it is through long-term monitoring programs we'll be able to detect. So we're looking at other indicators. So we've done nutrients, but we're looking at other indicators that we can add that a farmer can measure on their own farm or through a scheme from one point of time. And then if we repeat that in, say, 5 years' time, you can see the change on a farm.
Hiya. What was my question? Do you have any more research? Well, you mentioned the biochar there. Just wondered if you could maybe let us know any more of the research that you have found on its benefit to soil so far.
We know it increases carbon. The carbon content is the main sort of focus of use, the main reason for using the biochar, but we've only We've only started this research on how it holds on to phosphorus and potassium and other nutrients, but it's whether that, how that affects yield and how it affects nutrient movement in the soil. That's what we're looking at now, because if it holds on to it, it might reduce the amount of loss of those nutrients, but as whether how they will be released over time. We're looking at how quickly does the biochar release the nutrients? Is it within a season? Is it over a number of years? So it's a bit of a long-term research platform there, but it's ongoing.
Yes, that they that it holds on to the nutrients too tight for the plants to access in time, sort of thing?
Yeah, like it'll only be an issue I would say in the springtime or the summer where there's rapid growth. You want your nutrients to be really available, but if the biochar is holding on to them, and it might slow down that release for plant uptake, that's where it would be an issue. So that's why, but that applies to a lot of organic materials. So if you apply fertilizer, artificial fertilizer, the nutrients are readily available, but any kind of organic form, they're released more slowly. So it's whether there's enough nutrient there to keep up with rapid crop growth at the time you need it. That's kind of the question. But there would tend to be slower release.
So are you advising farmers to use any of the proposed regen type of things to improve their soil health, such as multi-species storage?
Yes, so we are doing a lot of work on multi-species, particular clover in terms of reducing nitrogen inputs. So clover is really, we all know it's really good for that. It's whether it's the persistence of it. So we know, it doesn't maybe persist as long, you have to reseed. It's whether how it's affected by pH and moisture across Northern Ireland, whether it grows as well everywhere. We're also looking at plantain, chicory, even timothy, different grass varieties we're looking at to see how well they grow in different parts of Northern Ireland. That's our main thing. So we know clover will reduce nitrogen sort of fertilizer requirements, but how well it grows depending on pH and moisture and things like that. So we're trying to then advise farmers, so does it grow as well as Fermanagh, as County Down, for example, or what kind of how do people manage it? When do you sow it? Does it sow better? Does it establish better in the springtime or summer, late summer or autumn? Things like that. When you sow it, it's very important whether it establishes well. How do you handle weeds? There's a lot of different questions we're looking at, but we do have quite a few multi-species trials and grass clover trials as well.
I have sort of a silly question, but I am quite interested in like soil and how it is defined, or is it defined in a different way within your context, or like what is soil?
Well, when we talk about soil health, it really needs to be talked about in the context of the land use. So a healthy agricultural soil is different from a healthy woodland soil or a peaty soil, for example. There are different characteristics you would expect depending what that soil is used for or the crop that they're trying to grow. So obviously the things in an arable soil you would have the way it's managed as affects the health and the characteristics of that soil, and that is right for that land use, but it's very different from a peaty soil, for example. So you have to define it in the context of what the soil is used for, in a way. Hope that answers your question.
Yeah, thank you.
That one, oh yeah, so that one's wrong. This is the
Sorry, I have possibly a difficult question for you. You might want to answer it. We live in a time when our waterways are in dire trouble, and there's a lot of debate as to the cause of it and not the cause of it. You mentioned that you're marking the copybook of every farmer, and farmers are very hurt, and understandably that everybody seems to be blaming them. Now, it's all very good marking the copybook of each individual farmer and telling them what the story is. To what extent will you put the information, obviously confidentially, you won't be identifying farms, but regions, will you be making that public? So, like marking Northern Ireland's copybook, and making it public what the challenges are and what we need to do within the farming community, because while I'm not saying it's completely the fault of the farming community, it's important to know what can the farming community do to help in the dire situation we are with the waterways.
Okay, so we're scientists and researchers, so we present what we see, but we're more interested in the scientific sort of findings, but it's not. Sorry, I'll maybe get Rachel to answer this. We are not. Okay, I'll get Rachel to answer this.
Okay, I'm going to try to. I suppose we are looking at the results across Northern Ireland as they come in from the Soil Nutrient Health Scheme, across carbon, across phosphorus, potassium, pH, everything. And we have that access to that data for research. So we will look, at catchment level at a big scale, where there are higher levels of this and lower levels of that, and try and make sense of them. And some of that, information would help us identify catchments that maybe need more investment in terms of agri-environmental schemes. Where could we're also through the LiDAR risk maps looking at, areas of high runoff risk, areas then that have, arable areas where there's a lot of bare soil, areas where there's high phosphorus. These are areas that, agri-environmental schemes going in on the ground could have a lot of impact quick, perhaps. And I suppose the plan would be, I think, that at a very big scale and absolutely not identifying any farmer or even group of farmers, that information could be used to direct those voluntary measures and advisory schemes. It's written into the Soil Nutrient Health Scheme that it will not be used for enforcement or anything like that on farms, and it won't be. But I think it's such a valuable source of information that we could use it on a guidance and target an approach for investment and improvement, and giving farmers in particular areas access to schemes that would benefit them and the environment. So I think, yes, at a big scale level, the information it's a benchmark for the whole. It's a benchmark we've never had in terms of looking at the soil resource. It also helps us identify areas where the issues with water quality are nothing to do with agriculture. And it's not a blame game, but we need the information to know where resources for urban areas, industry, wastewater, everything needs to be a scarce amount of money spent well. So if we can use the information in that way, I think there are benefits for everybody. That's just what I think.
Sorry, it's just taking on another wee step from that in terms of using the soil nutrient scheme results effectively. Say, for example, within the context of dairy discussion groups, obviously they'll have their own individual data, but the benchmark themselves across the likes of Northern Ireland, having a kind of even a benchmark for what those other farmers are doing across the whole of Northern Ireland, then that allows them to put themselves into a bit of context as well. And just to follow on from that, I guess it is public money at the end of the day. But it's not without any names. Like, it's just to have a benchmark for the whole of Northern Ireland. Yeah, exactly. The whole of Northern Ireland's a fairly big scale. Like,
But
yeah.
it helps also, we can see the drivers of some of the change. So you can see where there's underlying geology having an influence. So the geology across Northern Ireland obviously influences our soil and the soil properties. So you can see where there's high magnesium in soil. It's actually from the underlying bedrock that that soil is going to be high in magnesium because it's a certain type of geology underneath, or it's a limestone soil because of the bedrock. So you can see the drivers. We can see where there's high rainfall areas, there's a tendency to potassium deficiency. So potassium is one of our main crop nutrients, and we can see in the high rainfall areas in Northern Ireland, there's an overall tendency to deficiency in potassium. And you know, it's a trend, it's a like attribute of our soil and climate. So it's more to get these patterns across the country which are related to things other than management. It can be the underlying geology, the amount of rain, you know, they're all things that affect our soils. You know, mountainous area, that's where you get the peaty soil. You know, you can just see the character, it's more than management is affecting our soils. So, you know, you can see those patterns once they're mapped at a bigger scale. So it moves away from an individual farm, and it moves away from an area of Northern Ireland, just from, you know, the broader other, you know, underlying factors. So it's important to look at those and recognise those in the whole sort of soil health sort of topic, in a way. Okay, thank you. Thanks.